So the sun flares from these spots. The flares fling energy at us, electromagnetic energy. It arrives very quickly. And sometimes, often, the flares also have this plasma component, which takes time. It takes a couple days to reach the Earth. How fast it reaches the Earth depends on how fast it was flung off, because it's physical stuff moving through space. In any case, I think it's very clear that the aurora reached to extraordinary levels in light of the historical capacity of a storm of this size to reach that far, and that is perfectly consistent with this model that says the magnetic field is weakening, which it is, and that the weakening is accelerating, and that ought to be calling our attention to the other part of this phenomenon. Yes, we get the beautiful lights in the sky, but we are endangered because those solar storms that are caused by the coronal mass ejections place the grid in a dire kind of jeopardy. The
earthly electrical grid.
Yes. Now, there were many failures from this storm, failures of communication systems, satellite systems, including a GPS system that is used for farming somehow. So there were lots and lots of failures. We did not see major grid failures, but that is on the table to be caused by these solar storms. And unfortunately, what people don't realize is that the thing, if the transformers are blown by having this electromagnetic excitement fry the circuitry, they are not easily replaced. And it can, if you were to order one of these transformers today, it would take at least a year for you to see it. If we needed a bunch of them because a major solar storm had fried a bunch of these transformers, the Earth would be in very serious jeopardy. And so, you know, in conjunction with the excitement about the amazing display we saw in the sky, people should not be panicking, but they should realize that we are running a risk. I understand it to be a 1 in 8 risk every decade of a major grid collapse as a result of a solar storm. And the last time we had a major impact was in 1859, when the world was not a heavily electrical place. Very intense things were seen in the telegraph network, including fires and people being shocked at their telegraph stations, and the ability to send messages even with the telegraph not connected to power, because the induced current in the wires allowed the messages to be sent. But the point is, okay,
the ghost in the machine is plasma.
Yeah, incandescent plasma. There you have it. But anyway, we are potentially in increased danger because of the decreasing magnetic field, and we are running stupid risks regardless. So it would make sense for us to harden the grid, probably.
Right. So obviously there are some things the sun could do, throw at us, that there's nothing we can do about it. But we could be, and you have made this point over and over and over again, and we mentioned it even in our book. We mentioned Carrington events. We could mitigate this risk substantially, and by the standards of the federal budget, at very little cost.
Yes. And I've put 2 measures on the table. One is hardening the grid with respect to protecting transformers. The other thing that I think is a high priority, which I just don't hear people talking about, is the nuclear reactors and the spent fuel. We have decades of spent fuel in the fuel pools, largely stored above these reactors. And while
being cooled.
Yeah, they're being actively cooled with water. And if the water stops being pumped, it will boil off and they will catch fire. Right now, you can't, with the current dependence, which is not high, we're at something like 10% in the US of our power is nuclear. We could do without that. But with our nuclear reactors, we can't do anything about fuel that has recently been removed from the reactors. Those rods have too much of what's called decay heat. They can't be taken out of those pools. They have to be actively cooled for something like 5 years, if my understanding is correct. But a huge fraction of the spent fuel in those pools is not within that window. And it's old enough that there's not so much decay heat that you couldn't put it in what's called a dry cask storage. Dry cask storage does not need to be actively maintained, which meant that if the grid went down, the stuff in the fuel pools might be lost to the environment, which would be terrible, the stuff in the fuel pools and the stuff in the reactors. But if we could take the lion's share of the material out of that cycle.
And so the idea is that all of that lion's share, as you put it, would itself ignite if it was next to the stuff that is fresh.
That's
so all of it
exactly.
would ignite, and we can get rid of a bunch of the fuel and store it somewhere where it would not ignite because it can be stored safely without active input of electrons.
Right. And I'm not saying that those reactors and the 5 years of spent fuel that's too hot is not a major catastrophe in and of itself. It is. But the idea, you don't want to compound it with all of the stuff that could be problems.
Well, I mean, here's a failure of language, right? It's a major catastrophe either way. What's the problem? Like, why are we talking about this when we could solve other problems? Like, no, major, it doesn't equal major,
yeah.
right? And we could talk with high precision, potentially, although we don't have the technical details to know exactly what the numbers are, and it doesn't matter. What matters is actually an extraordinary tragedy could be mitigated and turned into a different level of still extraordinary tragedy that was orders of magnitude less.
Yep. And the point is in both of these cases, the hardening of the grid and the massive reduction in the amount of spent nuclear fuel that requires vigilance to keep it contained, those things are very cheap relative to the risks we are running. So the point is, it's not that we want you to be afraid. The opposite. What we want you to do is realize we're focused on the wrong stuff, and that actually our ability to mitigate the hazards to us is greater and cheaper than we think, and it does not require tyranny or any other such thing. It just requires us to focus on this thing, which at the point that you definitely know for sure that this really is a problem, it will be too late. And that if you just simply take what happened in 1859 and transport it to the present, we have a huge problem, right? Every system, the systems that feed us, the systems that purify and distribute water, every system is highly not only electrical, but electronic, which makes it sensitive. So it's time to get serious about it.
The cynic in me thinks, but where's the enemy in that story, right? That is an Earth unifying story, or at least a nation unifying story.
Yep.
And every nation should be interested in every other nation also doing the work and, helping each other if possible, because we all will benefit if, less spent fuel gets incinerated and fewer people have their entire grid destroyed and are therefore desperate and hungry and violent crossing borders.
Yep.
Right. So, the enemy is something that doesn't have it in for us. It's just a fact of life. And that is much harder to create ideology and win elections over.